Our last section from Chapter 2 is on variation, Section 2.5. And these are real-world problems that we're going to use mathematical models to solve. They are examples of relationships between two quantities. So when we talk about variation, we're going to look at two types. The first one is direct and the second one is inverse. But there are other types of variation in the textbook, but these are the only two we're going to consider. So the 3 bullet points there give you some examples of two quantities and their relationships. So let's look at this first definition. Let x and y denote two quantities. Then y varies directly with x. Another way to say that is y is directly proportional to x if there is a non-zero number k such that y equals k times x. Of course, k can't be 0 because that would just make y equals 0. The number k is called the constant of proportionality. The constant of proportionality. It stays the same for each unique problem, right? So depending on, each different scenario, k is a constant, and then x and y change here directly for this type of variation. What does that mean? That means as x increases, then y will increase. If x decreases, y will decrease directly. They work together directly. So here's an example of direct variation. At Kevin's hourly job, his monthly paycheck varies directly. So the problems will tell you what type of variation. And we're going to have two. This is our first one, directly, with the number of hours he works. So his paycheck varies with how many hours he works. Last month, he worked 82 hours and earned $963.50. Part A says to find a model, a general formula that relates his paycheck P to the number of hours worked. And I'm going to use a lowercase h for my number of hours worked. Okay, so it says his pay varies directly with hours. I'm just looking for the key words. Pay, so instead of y varies directly with x, it's p varies directly with h. Just substituting different variables, but it's the same idea. Pay varies directly with hours. Okay? And we're to find a model for Kevin. This is just a general model, works for any situation like this with paycheck and hours. But for Kevin, what is it? Well, we know that Kevin we know that P is $963.50 when H is 82. If we know two of the variables, we can find the third, so we'll find K using that information. $963.50 equals K times 82. So divide both sides by 82 and we get K equals 11.75. Okay, so for Kevin, the general formula, this is what we mean. For Kevin, his pay is equal to 11.75 times H. That's what we were looking for. Not this. This is generic. But here's the general formula for Kevin's situation. Okay, what does the K represent in the context of this problem? What do you think that 11.75 means? Right, this is Kevin's hourly wage, isn't it? Of $11.75 per hour. That's what it represents in this problem. Okay, now it says to use the model we found in A, the P equals 11.75 H, to determine his paycheck if he works 52 hours. So P equals 11.75 times 52, and that comes out to be $611. So in other words, he'll make $611 if he works 52 hours.